Hello students, welcome to the course Physics Principles and Applications for FYBSc Physics Paper 2 Semester 1. We are studying the fourth chapter, Sources of Electromagnetic Waves. In the previous lecture, we have studied the different types of electromagnetic waves, and in the previous lecture, we have studied the various types of electromagnetic waves and their sources. In this lecture, we are going to study the applications of electromagnetic waves. So, let us study what are electromagnetic waves. Electromagnetic waves or EM waves are waves that are created as a result of vibrations between an electric field and a magnetic field. In other words, electromagnetic waves are composed of oscillating magnetic and electric fields. So, this is the electromagnetic spectrum in which the various electromagnetic waves are placed according to their frequency or wavelength, right. Going from left to right, we can see the increase in the wavelength of the electromagnetic waves, whereas the frequency goes on decreasing in going from right to left, right. That means the gamma rays having the smallest wavelength compared to all the electromagnetic waves. We can see the gamma rays, they are having highest frequency radiation, and therefore their energy is highest among all the electromagnetic waves. So, we have seen different types of electromagnetic waves such as gamma radiation, X-ray radiation, ultraviolet radiation, visible radiation, infrared radiation, microwave radiation and radio waves. So, we can see the ranges of wavelengths and frequency in the electromagnetic spectrum. The range of wavelengths, that is ranging from 0.01 nanometer to a few kilometers in terms of radio or long radio waves. So, let us now study the applications of various waves in the electromagnetic spectrum. Let us first study the radio waves. Radio wave communications signals travel through the air in a straight line, reflect off clouds or layers of the ionosphere, or are relayed by satellites in space. They are used in standard broadcast radio and television, shortwave radio, navigation and air traffic control, cellular telephony and even remote control toys. Radio waves are used for wireless transmission of sound messages or information for communication as well as for maritime and aircraft navigation. So, we know that the radio communication signal, right. So, television communication or radio communication, or we can say the mobile communication, all these communication, they are going through the radio waves, right. So, these radio waves, we can say this is one of the tower. So, this is one of the tower and this is another tower. So, radio waves, they are transmitted from one tower, they will be received by another tower and they will be transmitted at the other locations, right. So, in the atmosphere, we can say on the earth surface we have various network towers, and the communication between different towers that can be done through the layer of the atmosphere, that is ionosphere. So, we know that in our atmosphere there is one layer called as ionosphere. That ionosphere contains the ions of various atoms or molecules. When the radio waves are transmitted from the tower, they will be reflected back from the ionosphere and clouds, and therefore they will be received by another antenna placed at a far distance on the earth's surface, and therefore by using this technique we can do the long distance communications through the radio waves. The information is imposed on the electromagnetic carrier waves as a amplitude modulation or as a frequency modulation, or in digital form, that is pulse modulation. Transmission therefore involves not a single frequency electromagnetic wave, but rather a frequency band whose width is proportional to the information density. So, we know the amplitude modulation and frequency modulation in terms of radio communication, right. So, we know the radio sets, All India Radio. So, there we have the AM and FM bands. So, AM stands for amplitude modulation and FM stands for frequency modulation. In the case of amplitude modulation, what we have, the amplitude of the we can say the input signal that is modulated by using the standard frequency. So, we know the radio stations, various radio stations, they have the standard frequencies. Basically, for amplitude modulation, the frequencies are used in kilohertz, right. So, particular station has a particular frequency, let us say 500 kilohertz or 550 kilohertz. A particular radio station has it is transmitting the signal at 500 kilohertz. Then whatever the signal that is broadcasted there, that will be broadcasted at the same frequency, that is 500 kilohertz. So, let us say the input signal, that means the human voice, or let us say the some singer is singing a song, that we know the sound waves have frequency 20 hertz to 20 kilohertz, right. So, all these human voice that will be modulated in terms of this 500 kilohertz frequency set for that particular station, right. So, that voice will be modulated and in that frequency, and that will be transmitted. So, the amplitude of the voice that will be modulated in that frequency, and that is called as amplitude modulation. That means the amplitude of the transmitted wave that will vary, and accordingly we can listen the voice of the singer at our radio sets, right. So, when we tune our radio set at that particular frequency, for example 500 kilohertz, right. In the case of frequency modulation, the frequency of the input signal that will be modulated at the frequency of the, we can say, the FM center, right. So, FM stations, they have particular frequency. For Nasik it is 101.4 megahertz. So, usually the FM band is slightly higher frequencies. So, that frequency the input signal of the singer that will be modulated in terms of the frequency, and that will be received by our FM radios, and we can listen the sounds or whatever announcement that the radio jockey is making at the FM station. Radio waves are particularly important in astrophysics. The radio waves emitted by various celestial bodies like pulsars, quasars, galaxies, etc., which can be detected by using a radio telescope. One such telescope is installed at Khodad near Pune, called as Giant Meter Wave Radio Telescope (GMRT). The study of these waves gives more information about their sources, right. So, we know that the celestial bodies like pulsars, quasars or galaxies, they produce radio waves, and that radio waves produced by these celestial bodies, they will be transmitted throughout the space, and if we can measure that radio waves transmitted, that will give us more information about their sources. That means we will get information about pulsars or quasars or galaxies, and that can be done by we need very large antenna to receive such radio waves. So, near in India or near Pune, we can see the giant meter wave radio telescope GMRT is installed by IUCA, that is Inter University Center for Astronomy and Astrophysics, and ENCRA, located in the University of Pune campus. So, this GMRT telescope or antennas, array of antennas that are placed near Narayangau or in Pune district. So, this is GMRT telescope installed at Khodad in Pune district. Let us now study the applications of microwaves. So, microwaves can cause water and fat molecules to vibrate, so they are used for cooking in microwave ovens. So, we in our households we use the microwave ovens to cook foods, or even some restaurants they are using these ovens. So, in the microwave ovens we can see the microwave source is used, and that microwaves, when they are incident on the food, the water molecules inside the food, they will receive the microwaves and they will vibrate, and during these vibrations they will produce amount of heat, large amount of heat, and that heat will cook the food, right. So, in microwaves, microwave ovens, the microwaves are used for cooking the food, right. So, this is a typical microwave oven used in the households. They are used by mobile phones produced from a transmitter chip and antenna, as well as Wi-Fi. So, in mobile phones and in Wi-Fi routers, the microwaves are used. That means they are transmitted from the transmitter chip and antenna of the mobile phones. They are also used in radar, which is used by ships, aircrafts, and weather forecasters. So, we know the weather forecasters, or even ships or aircrafts, they have the radar, right. So, this typical radar antenna, and this is the we can see they have this kind of screen, and they can monitor the any movement of other ships or aircrafts on the on this dial, we can say. And even for weather forecasting, these satellites are used, and these satellites they use microwaves to transmit we can say microwaves, and these microwaves they will be reflected by the clouds, and since they will be reflected by the clouds, so we can take the picture, and we can easily we can forecast the weather conditions, right. So, one of the type of radar works by sending out burst of microwaves and detect echoes coming back from the object that the microwaves have it, and so can find the distance of the objects by detecting the time it takes from the echo to be received. So, this is particular radar antenna, and it transmits the radio waves. If you want to detect a target, let us say some aircraft is flying, so the radio waves they will transmit the the radar antenna, it will transmit the radio or microwaves in in the atmosphere, and that transmitted pulse, when it hit the target, the echo pulse will be generated from the target, and that echo pulse will be received by the receiver of the radar, and from that one can easily detect the target. Microwaves are also used in maser. A maser is a device similar to a laser which amplifies light energy by stimulating photons, right. A maser, rather than amplifying visible light energy, amplifies the low frequency, longer wavelength microwaves and radio frequency emissions. So, maser is a device that produces the microwaves. So, maser is a full form for microwave amplification by stimulated emission of radiation. So, just like laser, so in the laser we use the light radiation that will be emitted. In the maser, the microwave or radio frequency emissions will come out. So, this is the first maser that is built by Charles Towns. Let us now move to the infrared radiation. One of the most common uses of infrared radiation is in heat sensitive thermal imaging cameras. This can be used to study human and animal body heat patterns. They are used as night vision cameras. These have use in warfare as security cameras and in nocturnal animal research. So, this is particular infrared sensor installed at this camera, and we can sense the heats that is coming from the uh, hot bodies, that is, let us say, animals or humans, and that will be detected by this infrared camera, and we can see the night vision, right. So, most remote controls operated by sending pulses of infrared, spelling out codes that an electronic device will recognize. This includes TV remotes, DVD players, projectors, etc. So, in the television remotes or DVD player remotes or projectors, all these remotes, they use infrared radiation. Infrared is often used to send signals through fiber optic cables, particularly when using standard silica fibers. Fiber optic cables are commonly used to transmit audio to sound systems and for high speed internet connections. So, we know the fiber optic communication technology in which the light signal is used, but sometimes the infrared radiation may also be used in the fiber optic cables to transmit the information from one place to another place. Infrared is often used to send signals through fiber. Infrared spectroscopy is very important in laboratory. Infrared spectroscopy involves the interaction of infrared radiation with matter. It can be used to identify and study chemical substances including various solids, liquids or gases. So, we know that this kind of infrared spectrograph, so when the molecules they vibrate or rotate, so during the vibration they will absorb the infrared radiation, and because of that when we incident infrared radiation on these molecules, we will get much information from the spectroscopic techniques involved in the infrared Infrared is also widely used in astronomy. Taking pictures of the universe in infrared can lead to some amazing discoveries. Astronomers can look at an area of the sky that appears empty and dark in the visual part of the electromagnetic spectrum and find the area full of activity in the infrared, right. So, some of the astronomical objects or celestial bodies, they emit infrared radiation. So, sometimes we may not see anything in the sky, in some part of the sky, but if we use the infrared devices, then infrared devices they will detect the infrared radiations coming from that part, and we can see a large activity in that area, right, by using infrared radiation. Since most objects that are at all hot produce infrared radiation, whereas plenty of objects do not produce visible light. It is a vital tool in observational astronomy, right. So, therefore, many of the objects they may not produce the visible light, but they produce the infrared radiation, and from that we can easily detect the such objects by using infrared astronomy, right. So, Hubble Space Telescope was launched in 1990s. We have entered a new era in infrared astronomy. Space telescopes are able to conduct infrared photography with no interference from the Earth's atmosphere whatsoever. As a result, we have some stunning images that we could never have achieved on Earth. So, Hubble Space Telescope is one of such telescope that is placed in the outer space, and from there we can take pictures, infrared photographs of various objects. Let us now move to the visible radiation. So, lasers emit the radiation in the visible spectrum. The lasers are used in various engineering and industrial applications such as cutting, drilling, etc. So, we know the laser is basically emitting the visible radiation, and that laser radiation can be used in various industrial applications. Lasers are used in nuclear physics for artificial fusion and fission reactions. So we know that in nuclear physics the fission and fusion reactions are there. Lasers employ visible light that is used in techniques like holograph. Lasers are used in various military applications such as laser guided guns, missiles, etc. In laboratory, the UV VI spectroscopy is used to study various atoms and molecules that uses UV and visible light. The emissions and absorption spectra emitted by various atoms or molecules is in the visible region of the electromagnetic spectrum, and the study of the spectra gives more information of the atoms present in the given sample. That means if we do the emission or absorption spectroscopy of the visible radiation that is coming from the various atoms or molecules, then by using that spectra we can detect the information about the atoms present in the given sample. Also, the plants uses visible light in the process of photosynthesis to convert water and CO2 into glucose. Artificial photosynthesis is the novel way to mimic the photosynthesis laboratory and produce fuel. It involves water and carbon dioxide into carbohydrates and oxygen by using visible light. Photocatalytic water splitting converts water into hydrogen and oxygen and is a major research topic of artificial photosynthesis. That means by using the same technique of photosynthesis, we can produce or we can do the artificial photosynthesis in the laboratory. That means we can use water and carbon dioxide molecules to convert it into carbohydrates, and also the water splitting reactions we can use the water molecules. So water molecule, we know it has oxygen and 2 hydrogen. So when this molecule will be splitted, we can produce the hydrogen separate and oxygen separate, and by using this hydrogen we can use this hydrogen as a fuel. So this hydrogen fuel is we can say the water splitting reactions are a very important topic of research. Visible light communication systems which employ visible light. The low bandwidth problem in the RF or radio frequency communication is resolved in VLCs because of the availability of the large bandwidth. Potential applications of VLCs include LI or Li-Fi, vehicle to vehicle communication, robots in hospitals, underwater communication, and information displays on signboard. The Li-Fi uses visible light for communications to provide high speed internet up to 10 Gbps, right? So just like the Wi-Fi, in the Wi-Fi we have the radio or microwaves, that instead of using Wi-Fi, if we use the Li-Fi technique where the visible light is used for communication, and in this technique we can achieve a large amount of speeds, right? VLCs can be used vehicular communication for lane change warnings, free crash sensing, and traffic signal violation warnings to avoid accidents, right? So let us move to the next radiation, that is UV radiation. So we know the UV lamp gives off the UV light which attracts insects, which are electrocuted by high voltage wires near the lamp, so they won't land on the food and contaminate it, right? Ultraviolet rays can be used to kill microbes. Hospitals use UV lamps to sterilize surgical equipment and the air in the operation theatre. In water purifiers, the UV light is used to kill the microbes and make the water pure, right? So in the water purifier, the UV radiation is used to kill the microbes or purify the water. Food and drug companies also use the UV lamps to sterilize their products. So suitable doses of ultraviolet rays cause the body to produce vitamin D, and this is used by doctors to treat vitamin D deficiency and some skin disorders. UV visible spectroscopy uses UV light which can be used to study various atoms and molecules in the laboratory. UV rays are used in the technique called as UV lithography. The lithography used in microfabrication to pattern parts of a thin film or the bulk of a substrate. UV electron spectroscopy is used to determine molecular orbital energies in the valence region. So, there are various applications of this UV radiation, just like in the shopping malls we use the UV barcode scanners to scan the price and more information about the products, right. Let us now move to the X-rays. The X-rays is we use in hospitals. So, the most familiar use of X-rays is checking for broken bones, but X-rays are also used in other ways. For example, chest X-rays can spot pneumonia. Mammograms use X-rays to look for breast cancers. So, this is a particular X-ray of a chest. X-rays can also be used to kill cancer cells, but also kill healthy cells. So, must be used with much care. Other uses are in industry, at airports to check customers and baggage, and by art historians to see in a picture has been painted on top of an older one. So, this is a particular we can say X-ray machine installed at the airports, or we can say at the railway or stations to scan the baggage of passengers. X-ray diffraction is also very important in spectroscopy and as a basis for X-ray crystallography. The diffraction of X-rays by a crystal, where the wavelength of X-rays is comparable in size to the distances between atoms in most crystals, is used to disperse X-rays in a spectrometer and to determine the structure of a crystal or molecules. So, in the X-ray diffraction or X-ray crystallography technique, we use the X-rays. So, we know the wavelength of X-rays, that is of the range of 1 to 2.5 angstrom unit, and in this range the distances between atoms and molecules are also fall. That means, in crystals the atoms are placed in a particular pattern and their distances between the atoms, they are fixed, right. So, if we incident the X-rays on these atoms or molecules, the atoms, they form different kinds of planes inside the these crystals, and when the X-rays are incident on these crystal planes, they will be reflected, or we can say we can see the diffraction pattern, and from that diffraction pattern we can easily see the structure of the crystals, right, or determine the structure of the crystals. It is particular X-ray spectrometer, right. So, in which the X-ray tube is used to emit the X-rays. That X-rays, they will be passed through the collimator and the beam will be formed, and that beam will fall on the crystal sample, and that will be reflected or diffracted beam will be received by the detector, and we can say this detector that it can move to 360 degree throughout the crystal, right, and we can see the diffraction pattern on the film, and from that pattern one can easily determine the structure of the crystals of molecule. Let us now move to the next radiation, that is gamma radiation or gamma rays. So, gamma rays have the smallest wavelengths and the most energy of any other wave in the electromagnetic spectrum. These waves are generated by radioactive atoms and in nuclear explosions. Gamma rays can kill living cells, a fact which medicine uses to its advantage, using gamma rays to kill cancerous cells. Gamma rays are used in an industrial setting to detect defects in metal castings and to find weak spots in welded structures in a process known as industrial radiography, right. So, the gamma rays, they are having various applications in the industrial radiography technique. We can detect the defects in the metal castings, right, or in the metals, we can say. Gamma rays, namely in the form of a radionuclide called as cobalt 60, are used to preserve food in the same way as they are used to sterilize medical equipment, in that they irradiate decay causing bacteria. Cobalt 60 produces low amount of gamma radiation, which allows it to kill bacteria, insects and yeast without causing a lethal dose of radiation in humans. The process also prevents sprouting and ripening of fruits and vegetables, while otherwise causing no significant changes in the food's content. Therefore, the gamma rays, they are used to stop or prevent sprouting and ripening in various foods and vegetables like potato or onions or mangoes, right? So, in summary, we have studied the electromagnetic spectrum and different types of electromagnetic waves, and we have also studied the applications of various types of electromagnetic waves in detail. In the next chapter, we will study the applications of electromagnetic waves in detail. Thank you.